This is lesson 1.7 on rewriting formulas. The volume of a cylinder is given by the formula V equals pi times the radius squared times the height, where r is the radius and h is the height of the cylinder. Or if you think of a soup can, the height of the soup can and the radius would be on the end of it, the circular end of it. The formula gives the volume of it in terms of r and h. If you have values for r and h, you can use this formula to find v. So what that means is the formula gives the volume v. So in other words, v is on one side of the equal sign and the variables are on the other. So you can see v on one side and r and h on the other side. So v equals pi, which is a number, times r squared, there's one of the variables, r, and then h. So v is on one side. However, it's useful to solve a formula for one of the other variables. So we can rearrange this to solve maybe for r, the radius, instead of the volume, or the height instead of the radius or the volume. And we're going to do that in example 1a. So Justin Case is an engineer for a barrel manufacturing company. He wants to design a cylindrical barrel to contain 500,000 cubic centimeters of liquid, and is considering several different radii and heights. So several different radiuses, in other words, radii is plural for radiuses. To do this, it is useful to solve the volume formula for h in terms of r. So part A, solve the volume formula v equals pi r squared h for h. For h, so that means h is going to be on one side of the equal sign in terms of v and r. So we got to rearrange that v equals pi r squared h, so we have h by itself. So v equals pi r squared h. We're going to divide both sides by pi r squared. Pi is going to cancel out, the radius squared is going to cancel out, and we're left with h on the one side of the equal sign. So h equals volume over pi r squared. We have just solved the formula for h, so h is by itself on one side of the equal sign. Now they want, in part B, find the height of a barrel with radius 30 centimeters that will contain 500,000 cubic centimeters of liquid. So we have the radius r and we have the volume v. So we're going to use this formula we just did, which we solved for h, to find the height of the barrel. So h equals v over pi r squared. The volume is 500,000. We have pi still, and then the radius is 30 centimeters squared. 500,000 divided by pi and divided by 30 squared. Make sure you square the 30 first, so it would be 500,000 divided by pi. 30 squared is 900. So now divide 500,000 by pi and 900, and you should get approximately 176.8 centimeters. So that would be the height of the barrel that could hold 500,000 cubic centimeters of liquid with a radius of 30 centimeters. Okay, in example 1b, we're going to use a different formula. The period p of a pendulum is the time in seconds that it takes a pendulum to make one complete swing back and forth, and is calculated by using the formula p equals 2 times pi times the square root of L over G, where L is the length of the pendulum in meters, and G is acceleration due to gravity. In this case, it's metric, so it's 9.8 meters per second squared. So now we're going to solve the formula P equals 2 times pi times the square root of L divided by G for L. So we're going to have L on one side of the equal sign. So okay, so let's write it again. We have P equals 2 times pi times the square root of L over G. Well, we need to get rid of that square root because that's no fun to deal with. So how would we get rid of a square root? Well, we know, like for example, the square root of 3, to get rid of that, if you'd square it, you get the answer 3. So to just have what's inside the square root, you have to square it. So we're going to square both sides of the equation. So we'd have p squared equals 2 squared is 4 pi squared is pi squared. And we know the square root of L over G, we would just have L over G left. And that's how we get rid of that square root. Okay, now let's divide both sides by 4 pi. Actually, 4 pi squared. That 4 cancels out, the pi squared cancels out, and we have p squared over 4 pi squared equals L over G. Well, we want to solve this formula for L. So we're going to multiply both sides by G. So we have p squared times G over 4 pi squared equals L. We have just solved the formula for L. In part B, it says, what is the approximate length of a pendulum whose period is 1 minute? Okay, if we look at the top, the period of a pendulum is the time in seconds. So we got to convert 1 minute into seconds, and we know that is 60 seconds. You got to be very careful with units. Okay, so now let's plug into our what we used here. So we had L equals p squared over G, or p squared times G over 4 pi squared. So let's plug all of that in so we can solve for the length of a pendulum. So L equals, P is the period of it, so we know that's 60 squared times G is gravity, which is 9.8, they gave that to us, divided by 4 pi squared. 60 squared is 3,600 times 9.8 divided by 4 pi squared. To solve for all that, we would get 893.65 meters. That is the length of a pendulum whose period is 1 minute. Okay, in example 2a, I have it slid down the screen so I have more room to work at the top. It says another different formula. It says the formula C equals 65 times T divided by R minus 65. That computes the number of C hours needed for one car driving R miles per hour to catch up to another car that is T hours ahead and driving at 65 miles per hour. Solve the formula for T. So T is in the top. So we got to solve it for T. So we have C equals 65T over R minus 65. Okay, we want to solve everything for T. So we're going to multiply both sides by the denominator, R minus 65, to get rid of that denominator. That would cancel out, and we're left with C times R minus 65 equals 65T. Okay, now we're going to divide both sides by 65, so we have T by itself. And that cancels out, so then we have T equals C times R minus 65 divided by 65. We just solved the formula for T in terms of C and R. Okay, in example 2b, it's another formula, another problem. Because the density of air consumed by scuba divers increases as they dive deeper, they consume more air the deeper they dive. The formula T equals 30 times S divided by D plus 30 is used by some scuba divers to estimate the number of minutes T of air they will have at a depth D in seawater. If they consume a tank of air at the surface in S minutes, solve the formula for D in terms of T and S. So we're solving for D. We want D on one side of the equal sign. So we're going to say T equals 30 times S over D plus 30. I'm going to multiply both sides by D plus 30 because I want to get rid of that division, that denominator. They'll cancel away, and I have T times D plus 30 equals 30S. Well, now I'm going to divide both sides by T because I'm solving for D. I want D on one side of the equal sign, so I got to get rid of that T. So they cancel out, and we'd have D plus 30 equals 30S divided by T. Now you can do the railroad tracks, and we want to subtract 30 from both sides. So those are 0, so now we're left with D equals 30S over T minus 30. So let's rewrite it so I can put a box around it. D equals 30s over t minus 30. That is solving the formula for D. Okay, example 3a. Solve v equals pi r squared h for r this time. So we're going to solve it for the radius. So we can write it v equals pi times r squared times height. We're going to divide both sides by pi times h. Pi times h. And if you want to do the double railroad tracks, if that helps, you can. Pi's cancel out, h's cancel out. We're left with r squared equals v over pi times h. Now we want to get rid of that squared, so we just have r by itself. In order to do that, we need to take the square root of both sides. So we would have the square root of v over the square root of pi times h equals the square root of r squared is r. So we just solved it for r. In part B, assume a fixed volume of 500,000 cubic centimeters. Write the formula for r in terms of h only. So we're not going to solve it, we're just going to write the formula. So we have r equals the square root of the volume over square root of pi times h. So in this case, we know that the volume they said was 500,000. And we can say divided by pi times h. That's how we would write the formula for r in terms of h only. There you go. So the only variable we have in there is h. Example 3b, a certain ancient pyramid has a volume of x cubic meters. Each side of its base is 231 meters. Solve v equals 1/3 base times height for h. And that base, b, is the area of the base, not just a side of it, the area. And we know this is, if each side of its base is 231 meters, that base of that pyramid is a square with each side length of 231. So we know that area of a square is side squared, so 231 squared. And that area is actually b, so b would equal 231 squared. But we need to solve this for h first. So volume equals 1/3 base times height. We're going to divide both sides by 1/3 b. Those would cancel out and we're left with h equals 1/3, our volume over 1/3 b, but we know we can get rid of that fraction on the bottom and we can multiply and go 3v over b. And if you're not sure how to do that, make sure you come talk to me about that. That should go back to pre-algebra. Okay, now we need to solve for h. So we have 3 times the volume. And they gave us the volume here in part B. The pyramid has a volume of 2,614,689 cubic meters. So I'm going to move this down so we have more room. So h equals 3v over b. 3 times the volume, 2,614,689 cubic meters. And at b I said was up here, 231 squared. Make sure you square that 231 before you do your division, and you should get 147 meters for an answer. That's the height of the pyramid.